In this video, we're going to look at the two main types of quantities that are out there. And this should be review from grade 10 science, but we will see. Now, if you remember from grade 10 science, you're often talking about scalars and vectors. Okay, now this would have been in your little physics unit. You guys started looking at basic motion, and we talked about how there's two main types of quantities out there. There's scalar quantities and there are vector quantities. And if you remember from last year, if you've got a scalar quantity, typically the typical definition that you'll have is this type of measurement only has magnitude, where the key difference between that and a vector is the vector quantity is magnitude but also has direction. So there's not much difference between them in terms of definition. One's magnitude and direction, but there's a huge difference in what you can do with vectors and vector analysis. Now, when you start looking at some classic things in terms of scalar quantities, you've got things like time is a scalar quantity. You've got things like mass is a scalar quantity, density. There's a whole bunch of different things. These are all quantities that don't have any direction associated with them. Now, of course, some of the ones that kick in are also very similar to vectors, and we'll look at that in just a second. But you've got vector quantities out there. For example, things like force is a vector quantity. We've got things like weight is a vector quantity, and weight is actually just a modification of force, and a whole bunch of others. Now, there are certain quantities out there that are very, very similar to each other. One's like the scalar version, and one's the vector version. So if we look at a couple of those, let's see, if we had like if you have the scalar version and you've got the vector version, you've got some simple ones like speed. Speed is a scalar quantity, but if you add direction to it, it actually turns into velocity, which you should be familiar with. We've got other ones. For example, we've got distance. Distance is a scalar quantity, and if you add direction to it, it is displacement. So hopefully stuff like that sounds familiar. And of course, there's a whole bunch of other ones that can go back and forth. But these are like the two most common ones that are very, very, very similar to each other, but one's got a scalar version, and then there's also a vector version. So let's look a little bit at the main difference between the two. Of course, the main difference between the two is the whole direction thing. And that's the biggest difference between the two. And there's different ways to actually show direction. And can be the more challenging part between the two. The magnitude part is actually really, really, really simple. If you look at the whole magnitude part is really, really simple. It's basically the length of the arrow, and I think you should be familiar with from grade 10. I think they probably introduced to you that we can show vectors. We show vectors by just drawing arrows. So, for example, if you have a box and you have like two people pushing on a box. Well, that guy's leg's up in the air for some reason. And this guy is pushing with this much, and this guy is pushing with this much. Obviously, the guy on the right is going to win. And you don't even need to know the numbers or anything like that. Just by looking at the arrows, just by looking at the vectors to represent them, it shows you who's going to win. Obviously, the box is going to go to the left, and just looking at it, I would say that this guy is pushing twice as hard. Now, how do I know that? Well, just by looking at the vectors, this one is about 2 times longer than this one. So just by drawing simple arrows, I can see who's going to win, I can see how much they're going to win by, and I can actually compare how much they're actually pushing. And this is like the huge advantage and wonderful thing about vectors is just by drawing a quick little sketch, a couple of arrows, you have a good idea what's going on. And trying to verbalize this could be really, really difficult and that type of thing. So it's a lot easier just to draw arrows, get a nice little visualization of what's going on. It works fantastic. So if this guy, for example, was pushing with maybe 50 newtons, I would guess this guy's probably pushing with 25 newtons because it's about half as big. So the magnitude is given by the length of the arrow. Now, the other part, of course, that kicks in is the direction. And there's a few different ways that direction can be shown. One way that is shown is to use things like, you say left or right, up, down, simple stuff like this is used. You can also use compass directions like the north, east, southwest, that type of stuff. You can also just use positive or negative. Is another really common thing used for showing direction. And then the other one is just use straight up angles like from a protractor or stuff like that. So these are probably the most common 4 ways that direction is given. Sometimes they're using combinations with each other. It totally depends on the situation. It totally depends on information you're given, and depends what actually is going to be easier. I mean, a lot of it has to do with make things easier and easier to relate to, but sometimes you need like really good precision. And it totally depends on the setup and that type of stuff, and people have different preferences. But let's look at some of how we can actually work with this type of stuff. And vectors are all about drawing diagrams, drawing vectors, that type of stuff. And we'll sort of show you how this type of thing actually works. So let's clean this up and then give us a little bit of space and show you how this works. Okay, so I just put some stuff in the top right-hand corner as a reminder, but let's just the best way to do it is just to jump in and just start by doing some stuff. So suppose we're not going to worry about kind of quantities, it doesn't make any difference, but suppose I asked you to draw a vector that represented 3. Now, that's not a lot of information right there, but if you have an idea of how vectors work, it's actually pretty simple. For example, I would probably maybe draw something like this, and that could represent 3. Another common example would be to draw something like this. Now you're going, well, how do I know which way to draw it? Well, there's actually direction given. It's actually kind of hidden a little bit. This is a positive 3, and when you have positive values, just like based on a standard Cartesian like graphing plane, positive axes go to the right and a positive axis goes up. So plus 3 would mean 3 to the right or 3 up. The same way, if we were going to draw minus 2, if I was going to draw minus 2, instead of going to the right, I could draw to the left. Now notice I made it shorter than this one. If that represents 3, my one representing 2 should be shorter. And same thing here, instead of going up, it would go down. And that's basically the idea behind drawing vectors, positive, negative, and simple things like that. Okay, so if I had to draw maybe, let's say I had to draw, 5. Well, if I had to draw 5, well, it might be something like this, longer than my 3 and to the right, or it might be something like this. And if I had to draw just -1, well, that's pretty simple. My -1 could be like a little tiny nub going to the left or a little tiny nub going down, something like this. And that's the really easy thing about drawing like positive, negative numbers and stuff like that. It's pretty straightforward. Compass directions are a little bit different. The angles kick in. So let's try that a little bit. Suppose we wanted to draw, let's say you want to draw 4N, and N would stand for north. And of course, standard type stuff, north goes up. So it might look something like this. That would be 4 going north. All right. Maybe we wanted to draw 3 SW, and SW stands for southwest. Now, that means south would be down, west would be to the left. I mean, your standard compass, north, east, south, west. Never eat soggy wieners or never eat shredded wheat, however you remember it, doesn't matter. But southwest is, south is down, west is to the left, but it's not random. When it's like the exact southwest, northeast, whatever it is, they're exactly at the 45s. So I know it would go down, left, something like this, and it would be exactly, it'd be 45 degrees in there and 45 degrees in there. It's not random angles. They're exactly at the 45s. Okay? A little bit different is maybe I would draw 5 and say 20 degrees north of east, something like this. So this is 5. Usually I put at in between. 5 at 20 degrees north of east. So this is very exact. Now obviously north is up, east is to the right, so it's going up and to the right, but it's an exact precise amount. It's 20 degrees north of east. So I'm just going to draw a little reference here. A little reference. There's my north, there's my east. Now, it is 20 degrees north of it. So I'm going to actually use my little line tool here. Okay, so this would be east. If I went straight to the right, that would be east. But I'm not going straight east. I'm going 20 degrees north of east. So I'm going to start going east, and then I'm going to move up something like this, 20 degrees. So I would sweep out 20 degrees. So that would be 20 degrees north of east. The same way if it was south of east, I would have swung it down instead. So if I would draw my little vector, it's a little sketch, that's all this is. It would be something like this, and that would be a little 20 degree angle right in there. Okay, so that's generally how it works. And again, we'll do a bunch more stuff like this, and really the best way to learn this type of stuff is just to go through question after question after practice question, and you just keep on working with it, and this stuff kicks in. Okay, so that's sort of how compass directions work. Now, what about just straight up angle? Straight up angle is probably one of the most common ones. Between all these things, positives, negatives, and angles, straight up angles are probably the two most common ones by far. So what about just straight up angles? Like suppose, we'll start really simple. Suppose you want 2 at 0 degrees. Okay, well, you know how to draw 2, but 0 degrees, which way is 0 degrees? Well, it's actually based on your standard XY plot. And going towards the right, that is 0 degrees. Everybody says straight to the right is 0 degrees, so everybody knows exactly which way that is. So if I was going to draw 2 at 0 degrees, all I have to do is draw a line straight to the right, represents 2, and that would be 2 at 0 degrees. And then when you get the angles, if we modify this and get some angles, maybe we're going to use 4 at 50 degrees. Well, to do that, super easy peasy. I'll do a little swing here. If it went straight to the right, that would be 0 degrees. And if it's a positive angle, you swing up. And how far am I going to swing up? Well, I'm going to swing up 50 degrees. So something like this. And this would be 50 degrees right in between the x-axis and the line. So if I would draw it, it would be a line something like this. It would be 4 long. Seems a little bit long. Shorten that up a little bit, because it should be twice as long as the 2 I just wrote. And then this would be 50 degrees. And the angle is always, this angle is always measured from the positive x-axis, always. Okay, so it was a positive 50, so I swung up. So if it was negative 50, I would have swung down. Okay, so suppose I wanted to draw 3 at negative 20 degrees. Well, in order to do that, okay, instead of swinging up, I'm going to swing down. So I start by going to the right. And sometimes it's a good idea to draw a little reference. I often would draw a little origin, and I'd give myself like a little reference line. And if it was going straight to the right, that would be 0 degrees. But I'm going to swing this down negative 20. So it would be somewhere around there. So I would just swing it down 20 degrees. So that would be around 3 at negative 20 degrees. Okay. Angles, of course, can get a lot bigger. Maybe I want to draw 5 at 200 degrees. Okay, well, seems fancy schmancy, but it really isn't that hard. I'm going to draw a little axis again here, just for reference. So if I were to draw this one, here's my line. Maybe that's 5. That would be it going straight to the right. That's 0 degrees. So it's positive 200. So I'm going to go up. So I'm going to keep on rotating up. So that would be 90 degrees. 180 would be going the exact opposite direction. So I just need to go another 20, something like that. Okay, here, let's put the arrowhead on there. There we go. So that's a little 20 degrees right there. But it's always measured from the positive x-axis, wrapped all the way around, and that would be 200. Now, because of this, sometimes you get into quadrant 3. People actually think about it coming as a negative angle. So 200 degrees would be the same as negative 160 degrees, where you would swing this way 160. Some people, what they do, if it's in quadrant 4 over here, they'll just use negative angles for everything. So instead of, if you had something like this, and it was 350 degrees all the way around. Most people just use the -10 because -10 is a lot easier to visualize than 350 for most people. Okay, so this is generally how it works. This is generally how we sketch them and draw them, that type of stuff. Again, it's some of it, especially the bottom part here, it looks a little complicated and fancy schmancy. Once you get into it and you got it. It just sometimes takes a little practice, and that's exactly how you learn vectors and how to draw vectors and all that kind of stuff. Is just purely by going through questions, and it just all clicks. It's just good visualizations for different types of situations. Okay, so next we'll start practicing actually working these a little bit. Again, the two most common ones we will use by far will be using positives and negatives. Positives go to the right or up, negatives go left or down, and then we use a lot of angles as well. Okay, so we'll do some more practice of this type of stuff and sort of show you how it works, because again, the best way to learn this is just to jump into some questions and figure things out.